Bismillahirrahmanirrahim. My name is Dr. Umair Younas. I am Assistant Professor in the Department of Livestock Management, and today I am going to present the heat stress and its implications in livestock with special emphasis to the dairy animals. These are the contents of my presentation. Heat stress is a condition where animals generate and absorb more heat than they get easily rid of by respiration, the sweating, and the convection. Or it may be defined as a condition where animals fail to dissipate the body heat to maintain its internal or core body temperature. According to World Organization of Animal Health, there are certain physiological changes that may be seen in a heat stress animal like elevated body temperature, increased respiration rate, flared nostrils, and increased heart rate. And certain other symptomatic changes includes increased maintenance energy requirement, decreased dry matter intake, decreased milk production, and excessive sweating. According to researchers, there are certain hormonal changes that take place in a heat stress animals, like there is a decrease in the thyroid hormones, like thyroid stimulating hormone T3, triiodothyronine T4, thyroxine or tetraiodothyronine hormone. These hormones are linked with the metabolism. Similarly, the prolactin and oxytocin level of production is also decreased. Prolactin is responsible for the mammary gland development and the production of the milk, whereas oxytocin is responsible for the release of the milk from the udder. Correspond to that, adrenocorticotropic hormone, its level is increased. It is responsible for the release of the cortisol hormone from the adrenal gland, and cortisol hormone is kind of a stress hormone. Similarly, the glucocorticoid hormone is also increased. Certain other behavioral changes includes there is an increased visit to the watering trough, increased number of steps, agonistic behavior, aggressive behavior, dyspnea, and decreased time in lying down, resting time, and decreased time spent to the feeding. So when an animal feel heat stress, that animal try to maintain a constant body temperature of approximately 38.5 degrees Celsius by matching its internal heat production with the net loss of heat to the environment. There are two ways by which a cow or any animal is getting a heat load. Number one is from the environment, and number two is from the metabolic heat. From the internal body metabolic heat, animals getting the overall net heat load. So if we add the heat produced internally by the metabolic process and the heat gained from the external environment, and then subtract that heat which is dissipated to the environment by the process of convection, evaporation, conduction, then ultimately we get the net heat load that an animal is experiencing. So there are four heat transfer methods that are acting on an animal. Number one is a conduction, number two convection, number three radiation, and number four evaporation. Whereas the convection and the evaporation are directly linked with the wind speed. Greater the wind speed means greater will be the dissipation of heat. As you may see in this picture, when the environmental temperature gets 30 degrees Celsius, animals tries to get rid of heat stress by means of conduction, convection, and radiation. But as the temperature goes beyond the 40 degrees Celsius, the heat loss can only occur by the evaporation. This is how a heat stress animal looks like: open mouth, protruded tongue, and drooling of saliva and panting. This is a graph showing a thermoneutral zone. Thermoneutral zone in the middle of a graph, the white region between the lower critical temperature and upper critical temperature. Thermoneutral zone is that zone where its animal is feeling comfortable with its environment. So thermoneutral zone, it is different for the different animals. For the Bos indicus animals that are mainly present in the South Asia region, it is the 8 degrees Celsius to the 26 degrees Celsius, as compared to the Bos taurus that are the humblest animals of the European and American origin. Mostly the 5 degrees Celsius to the 18 degrees Celsius is the thermoneutral zone for the Bos taurus animals. The severity of the heat stress also depends upon the animal. For example, when we compare between the cow and the buffalo, the number of sweat glands per square centimeter of skin is 394 in buffalo as compared to the 2633 in the cattle. Also, the skin color of the buffalo is black, is quite dark due to the high density of melanocytes, and the hair follicle diameter and the hair density is 10 times greater in the cow as compared to the buffaloes. So it means the buffaloes are the more prone to the heat stress. So why we are studying the heat stress? Because the world climate is divided into 7 different climatic zones: equatorial zone, subequatorial zone, tropical, subtropical, temperate, subpolar and polar zone. Whereas those countries that lies on the line of equator or between the Tropic of Cancer and the Tropic of Capricorn, those are the tropical countries. Whereas the Pakistan lies 23.6 to 37 degrees Celsius latitude above the line of equator, and hence the Pakistan has the subtropical climatic conditions. Also, according to the American Meteorological Society, the polar fringe of the subtropics is at latitudes approximately 35 degrees north and the south respectively. These are the Sustainable Development Goals established by the United Nations General Assembly in 2015, and we are concerned about the SDG number 3, number 11, and number 13. The good health and well-being, sustainable cities and communities, and the climatic actions that are directly or indirectly linked with the heat stress, with the welfare of the animals. An animal having a 1600 pounds body weight that produces a metabolic heat equivalent to about 900-watt light bulbs. And if that animal is in the production phase, if we suppose that animal is producing 35 liters of milk, then that animal produces 17 metabolic heat 1700 watt light bulb. So how we know that the environmental conditions are heat stress? That is based on the temperature humidity index, which is a scale value representing the combined effect of air temperature, humidity associated with the thermal stress. It's a simple formula where we need to put the values of relative humidity, variable temperature. By using this formula, we calculate the temperature humidity. The different values of environmental temperature in the Fahrenheit and the humidity in percentage, but all of the values that are equivalent to the THI of 72. So according to recent findings, the 68 THI is considered as a ideal for the high milk producing animals. Then 69 to 78 as a mild stress, then 69 to 88 is considered as a moderate stress, 89 to 90 as severe stress, and after 98, this is a danger zone. There is a highly chances that animal may get die of heat. In this table, if you don't want to use the formula, then this is a simple table by which we find out the THI values. Suppose the environmental temperature is 90 degree Fahrenheit and the relative humidity is 10, then the THI value will be the 74. This is another picture showing the effects of heat stress on the animal, on the production performance of the animal. In this picture, as we can see, if the animal's heat stress, it shows the signs of panting, reduced feed intake, the decreased rumination, the drooling of saliva. All of these factors, they combine towards the less saliva production to the rumen, because saliva acts as a buffering agent in the rumen. So if the less saliva is going to the rumen, then the rumen pH goes down. So normally the rumen pH is 5.5 to 7.5, but this pH goes down by less than by 5.5, and this leads to a condition which we call as a rumen acidosis. Also, the heat stress animals also in the restless condition spends the less time in the laying, the resting phase. This leads to the another problem in the hoof of the animal, call it as a lamina. There are certain management strategies and trends that are helpful in mitigating the heat stress. For example, the use of the ceiling fan or the bracket fan, they are available in the market in the different size. Then use of showers is quite common and very effective in the dairy farms. Then is a mister system. Mister system use the pressure about 100 to 200 pounds per square inch, and the Doppler size it produces is about the 10 to 100 micrometer. And the mister system has capacity to reduce the environmental temperature by 5 to 8 degrees Celsius. And then is more advanced system is a Fogger system. It uses a high pressure 700 to 1000 pounds per square inch and produces a very fine droplet size of 0 to 10 micrometer, and then it has a capacity to reduce the microclimate temperature by 8 to 10 degrees Celsius. Then certain nutritional strategies may be followed, like increased feeding frequency, it may also increase the dry matter intake. And according to an other studies, the sodium bicarbonate may be added in the drinking water of animal at the rate of 2.5 gram per liter of water, and it acts as a buffering agent. It helps to reduce the condition of rumen acidosis. And it is better to use the nutrient density rich diet by using the concentrate and the dietary fats, which are the source of the non-fermentable energy. And when a farmer is in a very poor condition, if farmers don't want to spend money on these mitigation strategy, this is a very cost effective and very least cost strategy. Just provide the shade to the animals and provide fresh clean drinking water to the animals 20 on 24-hour basis. Certain gadgets used in the heat stress is a hygrometer, anemometer to calculate the wind speed, and at the temperature of 35 degrees Celsius, the wind speed of 15 km per hour or the 4 meter per second sufficient to create the evaporative cooling. Then is a non-contact infrared thermometer to calculate the skin temperature of the animal. This is a thermal imaging camera. It gives the idea about the which part of the animal body is more heat stressed. This is the weather station used to calculate the various parameters, various meteorological parameters like indoor outdoor temperature, indoor outdoor humidity, wind speed, atmospheric pressure, and also some calculation about the rainfall. Then scientists has used certain other technologies like electrooculography, electrocephalography, and electromyography to check the animals that heat stress animals they are restless, they have a very disrupt sleeping pattern. In the sleeping pattern there is a rapid eye movement and non-rapid eye movement. Both of these types are and there any sleep, the overall sleep the animal is affected. These are my some of publications in the Thailand, in the Journal of Dairy Science, Journal of Animal Science, American Dairy Science Association, in Turkey, in Europe, in Pakistan, in Bangladesh, in various other countries. Thank you so much.